Alright, so today we're going to talk about trig functions. There are 3 trig functions: sine, cosine, and tangent. You guys have probably noticed these on your calculator before. On your calculator, it's going to be SIN for sine, COS for cosine, and TAN for tangent. So that's actually how we're going to abbreviate these all the time. So what are trig functions? Trig functions are going to be used to find missing sides or missing angles of right triangles. They can only be used with right triangles for now. So if you're looking at a right triangle, let's say I had an angle. For now, we're just going to call the angle theta. So this is just like having a side labeled x. Theta right here, the symbol looks like this, and it's called theta, is just a variable representing an angle. It's a Greek letter. So if we have theta, we can actually describe all the sides of this right triangle. So the side across from theta is going to be the side opposite. The side next to theta is going to be the side adjacent. And then across from the right angle right here, always going to be the hypotenuse. So let's talk about what SOHCAHTOA is. SOHCAHTOA. This is actually going to help you remember the 3 trig functions. So the sine of theta, we're going to take the sine of this angle, is always going to be the opposite side divided by the hypotenuse. So it's always going to be opposite divided by hypotenuse. Let me flip sides on you. Cosine is going to be ca, and that's going to be adjacent over hypotenuse. And then finally we have tangent. Tangent is going to equal tangent of theta. It always has to be sine of an angle, cosine of an angle, tangent of an angle. It's going to be equal to opposite over adjacent. So now that we know what these 3 kind of look like, let's actually see what an example of this would look like. So let's say that I gave you a right triangle, and I told you this angle was 30 degrees, and that this side over here was 4, and I asked you to find the hypotenuse. So we already know 30, 60, 90 triangles. I'm just going to show you that this would work for any triangle, whether it's a special right triangle or any other type of right triangle. So first I want to look at the sides that I'm given. My theta is 30, the side opposite of it is 4, and then this is going to be the hypotenuse. So how I'm going to write this is first I need to figure out what trig function this is. So which one includes opposite and hypotenuse? Well, that's going to be sine. So we're going to write the sine of 30 is equal to 4, which is my opposite, over x, which is my hypotenuse. So now I need to actually solve this trig function. One easy way to solve this when you have x in the denominator is to put sine of 30 over 1 and then cross multiply. So sine of 30 times x is going to be x times sine of 30 is equal to 1 times 4, which is 4. We want to get x by itself, so we're going to divide by the sine of 30. So x is equal to, and then now you have to put this in your calculator. If you have the type of calculator that literally just whatever you type on here you can see, this is going to be much easier for you. So what you need to push in your calculator is 4 divided by, and then whenever you type in sine 30, you want to make sure you have the whole thing in parentheses. So I'm going to do parentheses sine of 30, and then end my parentheses, and I get the answer 8. If you have a type of calculator like what we use in class, you would push in your calculator 4 divided by, and then whenever you're pushing in sine, cosine, or tangent, you have to push the angle in first. So then you'd push 30 sine and then push equals, and you should get 8 as an answer as well. Those same directions go for if you're using your iPhone right now. You would need to push in your iPhone 4 divided by, and then 30 sine equals. I don't recommend using your iPhone. It's not very easy to use when you're using these trig functions. So I know I should have gotten 8 because this is technically a 30, 60, 90. We were given the short side and we need to go to the hypotenuse. The answer should be 8. So I just want to start off with a problem that we already knew what the answer should be. So let's try another example. We have another right triangle. I'm going to tell you that this angle is 42 degrees. We want to find out this side, and I'll tell you that the hypotenuse is 10. So first you need to figure out what trig function you're going to use. Here's my angle. This side right here would be the adjacent side, and then I also have my hypotenuse. So the trig function that uses adjacent and the hypotenuse is going to be cosine. So cosine of 42 is equal to adjacent, which is x, over my hypotenuse, which is 10. So on this one, it's actually much easier to get x by itself. To get x by itself, you just need to multiply by 10 on both sides. And see how those cross out? So now in your calculator, you need to do 10 times the cosine of 42. And you should get, you have to round your answer. We're going to round to 2 places. 7.43 is equal to x. Now, if you're using a calculator like the ones we use in class, you would have to put 10 times 42 cosine equals. You have to push the angle in before you push in cosine. Same thing if you're using an iPhone. All right, let's try one more example. Again, we have a right triangle. Let's say that I give you this angle and I tell you it's 33 degrees. And then the sides that I give you are x and 7. So first, let's see what trig function we need to use. I'm given the side opposite, and I'm given the side adjacent. So the trig function that uses opposite and adjacent is going to be tangent. So tangent of 33 is equal to x over 7. Now I just need to get x by itself. So I'm going to multiply by 7 on both sides. And now I need to do 7 times the tangent of 33. And we're going to get 4.55 if I round to 2 places. You're almost always going to have to round your answers whenever you're working with sine, cosine, and tangent. So that's what we got as our answer. Now I'm going to give you another example, and I want you guys to do this and have it ready for class. So here's our right triangle. I'm going to tell you that this angle is 70 degrees. And then I'm going to give you this side right here and tell you that it's 12. Have fun.